polynomial and rational inequality. Solving polynomial inequality. First, we rewrite the inequality so that all non-zero terms appear on one side of the inequality symbol. Next, we factor the polynomial into irreducible factor and find all the real zero of polynomial. List the interval determined by the real zero. Use test value to make table or diagram of the side of each factor in each interval. In the last row of the table, determine the side of the polynomial on that interval. Determine the solution of the inequality from the last row of the table. Check whether the endpoint of these intervals satisfy the inequality. This may happen if the inequality involves a less than or equal or greater than or equal. So first, example 1, x to the third plus x squared minus 16x greater than or equal to 16. So first we move everything to one side of the inequality to get x to the third plus x squared minus 16x minus 16 greater than or equal 0. We go ahead and solve this equation. X to the third plus x squared minus 16x minus 16 equal to 0. Factor out x squared. So the 0 are x equal 4, x equal negative 4, and x equal negative 1. Okay. So now we will make the table that contain the real zero and the interval. So the interval we're looking at is from negative infinity to negative 4, negative 4 to negative 1, negative 1 to 4, and from 4 to infinity. The test value, say x equal negative 5, x equal negative 3, x equal 0, x equal 5, and our factor is x minus 4, x plus 4, and x plus 1. And we reserve the last row for our result. Okay, so again, like we did before, we go ahead and determine whether in each interval, each of this factor is positive or negative. So here we get negative, 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 positive, negative, positive, 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 negative, negative, positive, positive. So the result, here we get a negative, positive, negative, and positive. And because our inequality is greater than or equal, we will include the endpoint in our solution. So then the solution here is from negative infinity to negative 4, include the endpoint. We want the part where it is greater than equal to 0. So then we're looking at negative 4 to negative 1, including the endpoint, union with 4 to infinity. Okay. So let's take a look at the next problem. In this one, everything already on one side of the inequality. I'll go ahead and solve the equation x to the 4 minus 12x squared plus 11 equal to 0. This factor to x squared minus 11 and x squared minus 1. So this is x minus a square root of 11 times x plus square root of 11 times x minus 1 times x plus 1 equal to 0. So the 0 are x equals square root of 11, x equals square root of negative square root of 11, x equal 1, and x equal negative 1. So then the table that we are looking at with the interval is negative infinity to negative root 11, negative root 11 to negative 1, negative 1 to 1, and 1 to root 11. Oh, last one, root 11 to infinity. Okay, so these are the intervals that we consider. Okay, we have test value. So root 11 is less than 4. So we'll do negative 4, negative 2, 0, 2, 4. And we look at x minus root 11, x plus root 11, x minus 1, and x plus 1. And we will have result in the last row. Okay. So fill this out. It be negative, 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 positive, negative, positive, 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 negative, 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 positive, positive, negative, negative, positive, positive, and positive. So overall, we have positive, negative, positive, negative, and positive. And in this case, we're looking for something that is less than 0. And because it is less than and not less than or equal, we don't include the endpoint. So the solution here of the inequality is from negative root 11 to negative 1 union with 1 to root 11. Okay.